Hello guys, good to see you back. Once again, I am back with a new project related Python OpenCV. And today in this project, we are going to replace green screen using OpenCV. We are going to use this green screen video and separate the person from the green screen and replace green screen with this background image. And you can use the same code to separate the green screen from your live footage also. So without wasting your time, let's jump into the Visual Studio Code editor. Before we start our coding, let me introduce you something. This project is part of my Mastering Python OpenCV course on Udemy, and as you can see, it is the new, fresh and bestseller course on Udemy. Till today, it comes with 11.5 hour plus content on it. And it comes with multiple real-world projects. So if you are interested to learn Python OpenCV from the very beginning, I will provide the link in my description. Just check this course on Udemy and you will understand why it has become bestseller. So let's back to the code. So as you can see, we are in my Visual Studio Code editor and I already created a Python file main.py. Now you can see in my current working directory, we have a image bg.jpg. This is the image that we are going to use as a background. And also we have a video file green.mp4. If I open this video file, here you can see a girl with green color background. We are going to subtract this green color background and isolate the girl from this image, from this video. Then we are going to replace the background with this image. So let's start the practical. So at first, I'm going to import the module. Import, and I'm going to import CV2. CV2. Then I'm going to import another module. We need NumPy. So I'm going to type import NumPy as np. After import both the module, now I'm going to load the background image. So here I'm going to declare another variable called background. Background equal to CV2 dot image read method, imRead. This one, then inside the round braces, here inside the single quote, I'm going to pass the image source bg.jpeg. After that, I'm going to resize the background using resize method. For that, I'm going to override this background variable. So I'm going to type background equal to cv2 dot resize. Then inside the round braces, here first we need to pass the image source. As a source, I'm going to pass background. Then we need to define the resolution. So here inside the round braces, I'm going to pass 640 for width, and for height I'm going to use 480. Here we resize this background image because this is the default resolution of our webcam. We can use this code with any separate green screen video. Also we can use this code any webcam. We can remove background using our live footage also. Next we need to load the video. For that I'm going to declare another variable called cap, cap equal to cv2.video capture method. Video capture. Then inside the round braces, here inside the double quotes I'm going to pass the file source green.mp4. Green.mp4. Here we use video capture method because this method can read our webcam. Then after read the video, I'm going to set a if condition. Here I'm going to set a if condition to check there is an error or not. So I'm going to type if not cap dot is opened, then inside this if condition I want to print something. Print inside the round braces, inside the double quotes I'm going to type video not found. Then I'm going to exit this program. Exit. Now the question is why I use this condition. If the source path is not correct, suppose green3.mp4, and as you can see in my current working directory there is no file such as green3.mp4, and save this file and run this code, in that case it's going to print this error message, video not found. After run this code, as you can see in my terminal, it print video not found. That's why I use this condition. It is up to you that you can use it or not. It is very good practice to handle the errors. Next, I'm going to run the main processing loop. For that, outside the if condition, I'm going to type while. This is the main loop. While true, then inside this while loop, I'm going to read all the video frame. For that, we need to use read method. So I'm going to type cap.read. And as you know, this read method return total two value, a frame and a boolean value. To store the boolean value, I'm going to type ret, and to store the frame, I'm going to type variable name frame equal to cap.read method. But before I do our further code, we need to make it correct. We need to make it green.mp4, not green3.mp4, because this file is not available in my current working directory. After that, I'm going to resize the frame. We need to match this frame, this video frame resolution, with the image background. For that, here I'm going to type frame equal to, basically I override this variable equal to cv2.resize method, resize. Then inside the round braces, we need to pass the source. So I'm going to pass frame, and then inside the round braces, after comma inside the round braces, we need to define the resolution, which is 640 by 480. Now after resize the frame, also we need to convert this frame into HSV color space, because by default OpenCV read our images into BGR mode. For that, here I'm going to type another variable HSV. HSV equal to cv2.cvtcolor method, cvt color. Then inside the round braces, at first we need to pass the frame as a source. So I'm going to type frame. Then we need to define the color code. So I'm going to type cv2.color underscore, and we are going to convert BGR to HSV. So I'm going to type BGR to HSV, this one. Now after convert it into HSV's color space, let's display the frame in a window. For that, I'm going to type imShow method cv2.imShow. Then inside the round braces, first we need to provide a window name, which is I'm going to provide dim. Then after comma, we need to provide the source. So I'm going to pass HSV, this one. After that, here I'm going to set a if condition for our wait key method to destroy all the window, which is going to break this main loop. So type if, and you know this process, if cv2 dot wait key, and I'm going to wait for 1 millisecond after press the key, and 0xff equal to ord method. Then inside the round braces, if I press q, small q, then inside the if condition, I want to break this loop. I want to break this while loop, break. And you know the process, after break the loop, also we need to destroy all the window. And also we need to release the camera, if you use camera. So it is good practice to release the camera. So I'm going to type cap.release method. Then I'm going to destroy all the window. So I'm going to type cv2.destroy all windows. That's good. And I'm going to save this file. Now let's save the file and run this code in my terminal and see, after convert this frame into HSV's color space, how it's look like. So I'm going to run this code in my terminal. So this is how it's look like after convert it into HSV. Now we need to create a mask for the green color. But before we create the mask, we need total two things: lower green value and upper green value. I want to say lower bound value and upper bound value of green color. For that, here I'm going to declare two other variable. Our first variable is lower green, lower underscore green. Lower green equal to, here I'm going to create a array using numpy. So I'm going to type np.array, then inside the round braces inside the square braces, I'm going to pass some values. At first, I'm going to pass 35. Then I'm going to pass 100. Then I'm going to pass 100 again. Now the question is, what is that? This is HSV color value. H represents hue, S represents saturation, and value represents brightness. The first value represents hue value. Hue represents the type of color. Then comes saturation. It represents intensity or purity of the color. And at last we have value. Value stands for brightness, brightness of color. For brightness, here we can pass value between 0 to 255. And as you can see, for brightness we use 100. Same as for the saturation. We can pass value between 0 to 255. And also for the saturation we use 100. And for the hue, we can pass value between 0 to 180. 0 degree represent red color, 60 degree represent white color, 120 degree represent green color, and 180 degree represent cane color. So this represent lower bound value for the green color. At the same way, we need to create upper bound value for the green color. So I duplicate this line and I'm going to replace lower with upper. And for the upper bound green, I'm going to take, for hue, I'm going to take 85 degree. For saturation, I'm going to take highest value 255. It means 100% saturation. And for brightness, also I'm going to take 100%. So I'm going to pass 255 again. And I'm going to save this file. So this code represents full green color and this code represents green color with dark shadow. So if there isn't shadow or dark part in your green screen, it can also detect as a green color and it's going to subtract it. So now we have upper green and lower green. Now we can create mask for the green color. For that, after HSV, here I'm going to type another variable called mask. Mask equal to cv2.inRange method. Here I'm going to use inRange method, inRange. Then inside the round braces, at first we need to provide the frame, in which frame we are going to implement the mask, which is HSV. After that, we need to provide the lower bound value. So I'm going to type lower green. Then we need to provide the upper bound value. So I'm going to type upper green. And I'm going to set this file. Now you might have questioned what basically it's going to create. How our mask look like. This method, the inRange method, create a binary mask, where black pixel represent with 0, it means nothing, and white pixel represent with 255, it means the green area. So if I try to show this mask image using image show method, so I copy this variable and replace HSV with mask and then save this file. Now you can see, if I run this code in my terminal, here you can see the binary image. So as you can see in this mask, white represent the green color area and black color represent the person. But we need to inverse this mask. To inverse this mask, we need to use bitwise NOT operator. So I'm going to type mask underscore inverse inv equal to, here I'm going to type cv2.bitwise NOT, this one. Then inside this round braces, I'm going to pass the mask. And before I save this file, I want to display this mask in this window. So I'm going to replace mask with mask underscore inv. And I'm going to save this file. If I run this code in my terminal, now you can see it inverts it. Now you can focus the person and remove the background from it. Now, from the real frame, we need to extract the person. For that, here I'm going to declare another variable called person. Person equal to, and I'm going to use another operator, bitwise AND operator. So I'm going to type cv2.bitwise AND, this one. Then inside the round braces, here I'm going to pass the real frame, the color frame. frame, comma, as a second source also I'm going to pass frame. Then mask equal to, this time I'm going to mask with this mask inv, mask inverse. So I copy this one and here I'm going to pass it. So using this mask inverse, we separate the person. If I run this mask inverse, as you can see, here it separates the person using this mask. Next, we need to separate the background. So for the background part, I'm going to declare another variable, background underscore part. Background part equal to cv2 dot, here also I'm going to use bitwise and operator, bitwise and inside the round braces I'm going to pass background. As a second source also I'm going to pass the background image, and then we need to set the mask equal to, this time I'm going to use this mask, mask, not mask inv. If you remember, you know that this mask represents the green area with white color, and this mask represents the person with white color. Basically here we inverse it, and we use this inversion to identify the person in the real frame, and we use the original mask to identify the background in this background image. Now if I show you the person, here I'm going to type person. Now you can see only the person in color. Let me show you. As you can see, here you can notice the person in color, not in bitwise operator. At the same way, if I show you the background part, and then set this file and run this code, now you can see the background only in color. Here you can notice the background only in color. Next, we need to combine the person and the background. For that, we need to use a method called add. So I'm going to type another variable named result. Result equal to cv2 dot add method. Add, then inside the round braces, first we need to pass the person, then as a second source I'm going to pass background part, this one, and here I want to display the result variable, this frame. So I copy the variable name and replace background part with result, and I'm going to save this file. After save this file, if I run this code in my terminal, here you can see the result, how it's look like, how perfectly it removed the green screen background and replace it with this image. So this is how we can replace green screen using OpenCV. Thanks for watching this video. Stay tuned for our next project.